Well, good afternoon. The idea of my presentation was to present you a technological demonstration about how to autoscale an SAP application in a public cloud, or so-called hyperscalers, as we discovered during the last day. So, well, to explain a little bit, I'm Philippe Jourdes, and I'm responsible here for oXya in Spain. What we do, for those who don't know oXya, we are a technical consulting company. So basically, we manage SAP-based services and the infrastructure in below. So it can be on-premise, in our cloud. But today we will focus on what can be done with the public cloud providers, Amazon, Azure, or Google. So since we started working, we developed a set of services regarding the cloud, and inside these services we have cost optimization and so on, who helps to manage the cost. And we also have new jobs regarding all the automation process and all the industrialization and automation that we can provide in the public cloud. So why autoscaling? With the public cloud, we usually have for web services like Apache, Tomcat, the capacity to autoscale on the fly when there is heavier load and when we need additional servers. We have features that helps us to scale up or scale down on the fly. Yet SAP is still more an on-premise application and has no capacity, and it doesn't know how to autoscale. However, what happens in a classic customer, there is a specific monthly moments where we have higher loads, peak loads. For instance, with financial closing, could be a marketing campaign, could be payroll. So we have heavier loads that we should be able to absorb. And on the other side, if we go more on a day-to-day activity, we have, for instance, at night, we have batch set, we have maybe a high peak of users that might connect at this moment of the day, etc., etc. So the idea would be to use the public cloud features to adjust the SAP consumption in real time in order to allow the SAP application to run with the minimum required infrastructure on a daily basis. So you set up your primary application server as low as possible, and then you would automatically provide additional performance when needed. So how does it work? Actually, quite simple. 4 steps. We need to collect metrics to know how, to know when we need to scale. So we first need to collect metrics on SAP system usage. And this can be any type of metrics. It could be classical technical metrics like CPU usage, RAM usage. But we can also dig in and use the log files to get subsystem usage, like the number of work processes available. This is the small demo we will see later. Then we need to detect. We collect metrics, that's fine. Then we need to detect if there is a requirement to increase or decrease, and based on threshold. So we will query in real time our SAP systems to know where we are. We will use serverless features, and thresholds are customer defined. We need to, we speak with the customer to know exactly what are the peak moments and when we should, what are the relevant thresholds we should set up. Then, when we know if we need to increase or decrease the number of application server, we can automatically add or remove an SAP application server. So scale up is quite easy. We add automatically an SAP application server to the load balancer, and then we can spread the load among these new servers. And the scale down feature is a little bit more tricky because we do not want just to shut down an application server. We want first to remove it immediately from the load balancer, so no new user can connect directly to it. It's outside, but we do not want to remove it directly, because if there is any job running, any user connected with long-running queries, whatever, we don't want him to delete his session. So this is why we do a SAP soft shutdown. we wait until the session ends, and then we shut down the SAP application. And then, of course, the idea of all this is to have some cost optimization. So we do the infrastructure decommissioning. And then next step is quite new now. It's in the roadmap, so we don't have developed it yet. The idea would be to use machine learning, since we have all these new features available, to define and use the metrics history and try to define patterns where autoscaling would be useful. So basically, the idea would be, let's say, every Monday morning, I have a heavy load, and when my query detects, today, I wait my query to detect there is a heavy load, and I add an additional application server. With machine learning, the idea would be maybe to have patterns and say, okay, we detect that every Monday by 10 a.m. There is high load. So predict and anticipate the requirements. Well, in terms of technology, yes, okay, same thing, same columns. So in terms of technology, collecting metrics, this is done using NoSQL DBs. So this is available in any of the 3 public cloud providers. Detect the increase and the decrease. So this is a Python script we launch using serverless features. So with a Lambda, Google Functions or Azure Functions. Automatically add or remove SAP application server. Said we use SAP standard features. So basically, what's happening really for this, we try 2 things. SAP allows to do so-called unattended mode installation. So we first tried, we said, okay, let's do it 100% virtual. When we want to add an additional application server, we run an installation in unattended mode, but it was too low. So it's working, but long. So in the end, we did the trick. We have some sort of ISO image of an application server, and we can start it on demand, and eventually clone it to add a new one. Well, and then machine learning. So before launching the demo, the idea we had in mind when we started the project was to make this a non-intrusive mechanism. So there is no ABAP custom code. There is no SAP technical user required inside SAP. We only use an access through operating system level. And we also were willing that this would be portable on any cloud platform. So we use for these portable technologies, Python scripting, NoSQL DBs. And regarding the SAP part, it's using SAP standard features and best practice. Let's try this. No? Okay. Okay. Yes. We'll do pauses. So here on this side, we have our Python script running on a regular basis and querying our SAP system to know, okay, to know if we reach a threshold. For the demo, the threshold is if there is less than one batch work process available, it means we are going to be stuck, so we need an additional application server. The demo has been done on Google Cloud Platform. So we can see here the portal. So there is only one primary application server here available. And this is inside our SAP system. We have, can't remember, it could be 12 jobs, random jobs, waiting to be launched. And here below, we can see the number of application servers in the load balancer. So what will happen when we launch the jobs? Okay. All the jobs are launched, and what happens? We can see 4 jobs are launched. So we are reaching the limit of our application server. A secondary application server is automatically started at the Google Cloud Platform level once it has been detected by the Python script. We can see it now in the SCM51, and then 4 new jobs can be launched. But since there are only 3 batches in the system, in the secondary application server, we need to add a second one. And it will be detected by Python and created automatically. So, okay, we have it now. All the jobs are released and running. Yes, now they are. So we will perform now the scale down. We cancel all the jobs, except one. So since the jobs are canceled, the query will detect that batch process are freed up, and we can run the soft shutdown of all the systems. This is what you can see. It's happening here and below. All the systems are being shut down, and they will, after the shutdown, also be shut down at infrastructure level. One thing, because I don't know when it will do in the demo, what we can see here, the last job, who is still active, is running. I don't know if you can read on application server number 2. And here we will demonstrate the soft shutdown capacity. So the application server 2 is also in a shutdown state. So it's pending to be shut down, but the job is still running. So we can see in the portal that AS1, AS0 will soon disappear. Here they are really shut down and out of the load balancer at SAP level. And here the infrastructure, the server is being really shut down. So we still have our application server 2 here because the job is not finished. The system is in pending shutdown, and now the job finished. And immediately right after, the application server 2 is out of the load balancer, shut down, and will be removed here. And well, basically that's it. Yeah, that's it. I will conclude quickly. Oops. Okay. So, as a wrap-up of this small demo, so SAP AutoScaling, as for now, today, sorry, is not a native feature. So we developed this feature, still using non-intrusive and portable mechanism. The idea is to be able to deploy it on any cloud provider. And where should we use it? Some sample use case would be high consumption and periodic process. If your productive system is heavy loaded during a short period of time or specific period of time, this can be useful. And we also have it in a customer who is using it as a testing process. By rules, they want to have pre-production the same as production. But in the public cloud, it's nonsense. They will eventually use it 2 or 3 days a month for a change release campaign, for training. So we don't want an SAP admin to be looking at, is my system heavily loaded? We don't want to know when they will perform a training. We don't want to know when they will test their change release. So basically with this mechanism, it's set up. And when the user are massively connected to the system, well, the load is adapted automatically. And so that's it. Thank you very much.